Okay, so next drug is the quinine. So when coming to the quinine, so it is present in the cinchona bark. So when coming to the cinchona, so like there are various species of the cinchona trees are available. So like the cinchona calicea, cinchona ledgeriana, cinchona officinalis, and the cinchona succiruba. So they all belong to the family Rubiaceae. So when coming to the chemical constituents, so apart from the quinine, so the cinchona, so it contains the other active constituents like the quinine, quinidine, cinchonine, and the cinchonidine. So when coming to this quinine, so it is having the anti malarial property. Okay, so when coming to the isolation part, so like you are going to follow the general isolation. So first you are going to take the powder, you are going to treat with the calcium hydroxide or calcium oxide or the sodium hydroxide. So means you are going to add any of the alkali solution. So then you are going to make it paste, then you are going to allow it to stand for few hours, then you are going to transfer that moisture mass into the oxalate extraction. You are going to extract by using the benzene. So as already discussed, so first you are going to set free the bases by using any of the alkali, then you are going to extract by using the organic solvents. So because these alkaloids, so they are having solubility in the organic solvents, hence you are going to use the organic solvent, so like the benzene or ether or so like that. So then you are going to take out that benzene extract, you are going to add the sulfuric acid. So why you are going to add sulfuric acid? So because it is going to convert the alkaloidal salt into alkaloidal bases into its alkaloidal salt, so like the quinine into quinine sulfate. So if you are going to add the sulfuric acid, so then this benzene layer is separated so from the aqueous layer, and you are going to discard the benzene layer. So because the quinine sulfate will be present in the aqueous layer, so then you are going to basify with the base or any of the alkali like the sodium hydroxide. So it is going to precipitate out the quinine. So then you are going to cool it. So upon cooling, so the quinine is going to precipitate as quinine sulfate. So then you are going to filter it. So for recrystallization, so you are going to use the alcohol. So then for apart from that, it contains a coloring matter. So for that you are going to use the activated charcoal or the ether. The quinine sulfate which is obtained is dissolved in dilute sulfuric acid. So then again it is going to make alkali with ammonia. So it is going to precipitate out. So then you are going to wash and you are going to dry. So here, like if you don't want to do the elongated procedure, so just you can make it simple. So first you are going to treat the powdered cinchona, that is the bark, so with the alkali. So any of the alkali like the calcium hydroxide, calcium oxide, sodium hydroxide, sodium carbonate. So any of the alkali you are going to take. So that is going to make set free the bases. Then you are going to extract by using the organic solvents, so like the benzene or ether. Then you are going to treat that organic layer with the acidic layer, that is the either H2SO4 or HCl. So that is going to convert the alkaloidal bases into the alkaloidal salt, so like the quinine sulfate and all. So that will be dissolved in the acidic layer as quinine sulfate. Then again you are going to make it alkali, so that is going to precipitate out the quinine sulfate. So that is filtered, and you are going to wash and you are going to recrystallize. So that this is the simple and the general procedure for the isolation of the quinine. So when coming to the identification test, so you can perform the specific test, that is the thalioquine test. So in this, so you are going to add a drop of sulfuric acid and you are going to add a 1 ml of water. Then you are going to add the bromine water dropwise, so till the solution is going to acquire permanent yellow color, and then you are going to add 1 ml of dilute ammonia solutions. Then the emerald green color is going to produce. So then it confirms the presence of the quinine alkaloid. So apart from that, you can go with the TLC. So in this, so you are going to use the methanol. So as a, when coming to the sample, you are going to use the methanol to dissolve the quinine. So when coming to the stationary phase, you are going to use the silica gel G. When coming to the solvent system, you are going to use the chloroform diethylamine in the ratio of 9:1. When coming to the spraying reagent, so here you are going to use the drag and drop reagent. When coming to the RF value, so RF value of the quinine is 0.1. 0.17. So in coming to the estimation, so there are various methods, so like the fluorimetry or the non-aqueous titration. So when coming to the, we can write any of the methods. When coming to the non-aqueous titration, so in this you are going to dissolve 0.2 gram of the quinine sulfate in 20 ml of chloroform and 20 ml of acidic anhydride, and you are going to titrate with the 0.1, that is the molar percolic acid. So you are going to determine the endpoint by using the potentiometry. When coming to the uses, as already discussed, the quinine, so it is having the anti-malarial property. So when coming to the quinidine, so it is having the cardiac depressant property, so hence it is used in the treatment of cardiac arrhythmias. Okay, so next drug is the reserpine. So when coming to this reserpine, so it is like present in the this Rauwolfia serpentina. So like when coming to the Rauwolfia serpentina, so it is the dried, that is the root. So it is also known as sarpagandha, so because it is having the snake like shape. So in coming to the biological source, so like it is the indole alkaloid, so which is present in the roots of the plant, that is the Rauwolfia serpentina, so which belongs to the family Apocynaceae. So in coming to the chemical constituents, so mainly it contains the indole alkaloids like the reserpine, ajmalin, ajmalicin, resacinamide, serpentine, yohimbe, and so on. So in coming to the uses, so mainly it is having the anti-hypertensive property. Apart from that, it is having diuretic, hypnotic, and the sedative property. Okay, so in coming to the isolation part, so as already discussed, so general methods. So first you are going to take the powder, you are going to add any of the alkali, so like the sodium bicarbonate or sodium carbonate. So then you are going to extract by using the organic solvents like the benzene. Okay, so then after that you are going to add the ether. So apart from that benzene, then the ether extract, so it is transferred into the separating funnel, and you are going to add the acidic, that is the dilute HCl. So then the alkaloidal bases, it will be converted into the alkaloidal salt, so like the reserpine, that is the hydrochloride. So then you are going to take out the acidic layer, and it is washed with the ether and it is filtered. Okay, so like after that to this acidic layer you are going to basify with the ammonia, and it is going to precipitate out the reserpine sulfate. Then you are going to extract by using the chloroform in a separating funnel. Then the chloroform layer is washed with the 10% solution of sodium carbonate, and it is evaporated to dryness. Then the residue is dissolved in methanol and allowed to cool when the crystals of the reserpine are obtained. So just simple. So you are going to moisten the drug with the alkali, that is the sodium carbonate. So then you are going to extract with the benzene, and if needed you can add the ether. So because this reserpine is having more solubility in ether, so then that reserpine will be moved into the ether layer. So then you are going to add the acid layer, that is the dilute HCl. So that will be convert the reserpine into salts, that is the reserpine hydrochloride. So then you are going to separate it out. Then you are going to add the ammonia solution, so that is going to precipitate out the reserpine. So then you are going to add the chloroform. So then you are going to wash that chloroform with the sodium carbonate, and you are going to evaporate it to dryness. Then the residue which is remained out for purification, you are going to dissolve in methanol, and you are going to evaporate the methanol. So then you are going to get the crystals of the reserpine. So when coming to the identifications, so you can go with the TLC method. So here when coming to the sample, you are going to use 1 mg of reserpine in methanol. So when coming to the stationary phase, so you are going to use the silica gel G. When coming to the mobile phase, here you are going to use the cyclohexane chloroform in the ratio of 3:7. So in coming to the detecting reagent, so here you are going to use the drag and drop reagent. So in coming to the RF value, so it is having the RF value of 0.35. So in coming to the spot color, so it is going to give you the orange colored spot. So like this is regarding the isolation of the alkaloids. So if you don't want the specifics, you can just write the general procedure. So just you are going to extract with the by using the alkali. So first you are going to treat the drug with the alkali, that is going to set free the alkaloidal bases, so because it is associated with the other compounds like the phenols or the tannins, so then it will be freed from those things. Then you are going to extract by using the organic solvent like the ether or the petroleum ether, benzene and all. So then because it is having more solubility, this alkaloid bases, then it will be moved into the organic layer because they are insoluble in water, they are soluble only in the organic solvent. Then you are going to treat with the this acidic or the acid, so any of the acid, so that acid is going to convert the alkaloidal bases into the alkaloidal salt. So once the alkaloidal salts are being formed, so you are going to increase the pH by adding any of the base, so then the alkaloidal salt will be precipitated out, that you can easily filter, then you can go with the recrystallization. So like this is the general method for extraction of any of the alkaloids.